The position of a particle is given by the equation P of t is equal to 1 divided by t. Find the derivative of P of t. Well, we know by the definition of derivative that P prime of t, or the derivative, will be found using the equation, or by finding the limit, as h approaches 0 of P of t plus h minus P of t, all divided by h. So let's actually use this formula in order to find P prime of t. So we still have the limit as h approaches 0, and then P of t plus h will be 1 divided by t plus h minus 1 divided by t, all divided by h. If we were to try to use direct substitution, we would get 1 divided by t minus 1 divided by t, so that's 0, over 0. So we can't necessarily do that. So in order to simplify this, what we're going to do is we are going to find the least common denominator for the two rational expressions in our numerator to be able to combine them together. And we're also going to get rid of this h that's in the bottom denominator. So first, to find the common denominator of the two smaller rational expressions, we're going to find our common denominator, which is going to be t times t plus h. So this first fraction has the t plus h, so we would have to multiply it by t divided by t. So that's how we get this t here, but then the numerator is also a t. And then the second one, the t plus h is missing, so we would multiply by t plus h over t plus h. So we would have t plus h as that numerator. And then we still have all divided by h, and we are finding the limit of this as h approaches 0. Now, in order to get rid of these rational expressions over h, let's multiply by 1 over h in both the numerator and denominator of the big fraction. So these will cancel out. And we can also combine these together and have that common denominator. So we're still going to have the limit as h approaches 0, but we're going to have t minus t plus h, all divided by t and h from here, and then t plus h. And then if we were to distribute this -1 through, we would have the limit as h approaches 0 of t minus h, all divided by th times t plus h. So we can clearly see that t minus t, that's 0, they cancel out. And we also have a negative h and an h in the denominator. So this h in the denominator is going to cancel out, and this negative h in the numerator becomes a -1. So we now have the limit as h approaches 0 of -1 divided by t times t plus h. And now we can use direct substitution with h being 0. And when we do that, we will have left -1 divided by t times, well, t plus h becomes just t, so t times t is t squared. And that's what P prime of t is equal to, -1 divided by t squared. Or answer choice C.